Often, our data will come in a particular shape that does not quite suit our needs. Say, for example, we have a data frame that summarizes a medical experiment. Each row is a single patient record with a patient identification number, the patient's gender, the type of treatment, and the measured response to the treatment. But perhaps we want to reshape the table to make it easier to see relationships between the response values, the specific treatments, and gender. This is an example of what is called pivoting our data frame. The pivot method lets us specify which columns to use as index and which to use as columns in the new data frame. We specified values equals response to identify entries in the reshaped data frame. The new table displays response values for each treatment and gender. The unique values of the treatment column, A and B, are the index labels, and the unique values of the gender column, F and M, are column labels. In the previous example, we specified the response column for the values of our pivoted data frame. However, we can also leave out this specification. In that case, all remaining columns are used as the values. The resulting data frame has multi-index columns with the ID and responses stratified by gender. Try using Pivot on your own in some exercises now. We've seen how the pivot function can rearrange columns of a data frame. We've also seen how to create a multi-level hierarchical index using setIndex. Remember, the input is a list of column labels to use as tuples in the multi-level index. Treatment and gender in this case. The pivot method won't work directly with this data frame because of the multi-level index. In this case, we might want to move some of the index levels to columns, making our data frame shorter and wider, more columns, fewer rows. To do this, we can move the second level of the index, the gender, to the columns using unstack. The data are now divided in columns by gender. This gives a similar result as the pivot method. The principal difference is now we have hierarchical columns. Earlier, we used level equals gender within the call to unstack. We could have specified an integer in the call to unstack instead. In this case, we want to unstack the second level, index equals 1, due to zero-based indexing. This yields the same result as before. The opposite of unstack is stack. This can be used to make a wide data frame thinner and longer. With unstack, you specify a level of the hierarchical columns to be moved to the index. Starting from our unstacked data frame, we can get back to the data frame with multi-level indexing with the stack method. When using the stack and unstack methods, we're dealing with hierarchical indexes. In the previous example, the gender level was added as the innermost component of the multi-index. But this is not always what we want. Suppose you want to have the gender level outermost and then the treatment level innermost. To switch index levels, we use the swap level method. We specified that we want to swap the first and second level here. Notice that the rows are still in the same order, so the index is not sorted now. The sort index method takes care of this. Now the first index level, the gender, is sorted. Try some exercises now to get used to stack and unstack for reshaping data frames. We've seen Pivot as a tool for reshaping data frames. Let's look next at Melt. This was the original data frame with single observations across the rows. This is what it looks like after pivoting. Suppose we obtain data in the following form. This is slightly different than our pivoted data frame before, where treatment was on the index. There are various contexts in which it is useful to switch from this pivoted summary to the original data frame. To restore the pivoted data frame to its original form, Pandas provides Melt. The Melt function converts our column labels for male and female into one column named gender, but the treatment index values are gone. This is not what we wanted. We can fix this by specifying the columns that should remain in the reshaped data frame. To do this, we specify ID vars equals treatment in a list. We can also list explicitly which columns to convert to values in the variable column of the melted data frame. Here we use value vars equals f in a list to get a different result. If we don't like the generic names variable and value, we can provide more descriptive strings with the keywords varName and valueName. Try the exercises now to get a sense of how MELT is used. We've seen Pivot and MELT as tools for reshaping tabular data, but Pivot doesn't always work. As an example, let's consider this tall, thin data frame resembling our previous treatment study. Notice that there are multiple rows with, for example, the combination of treatment A and gender M. If we want to apply Pivot to summarize the response values by treatment and gender, the repeated pairs make that impossible. Said another way, Pivot requires unique index column pairs to identify values in the new table. This is where a pivot table comes in. The pivot table method reshapes a data frame much like Pivot by summarizing the data frame with a pair of summarizing variables and their values. Pivot tables deal with multiple values for the same index column pair using a reduction. By default, the reduction is an average. Other aggregation strategies are admissible using the keyword agfunc. For example, here we use agfunc equals count to count the number of values that are present for each treatment gender combination. Thus, this pivot table is in fact a frequency table. Do some exercises now to practice setting up pivot tables.